Division by zero is an operation for which you cannot find an answer, so it is disallowed. The word division means splitting up a number into equal parts or groups so it is shared equally among everyone, whereas the value of 0 as a number is nothing. Another reason is that 0 has no multiplicative inverse, while in division a over b means ab to the power of -1. Logarithm is defined as the inverse operation of exponentiation. For example, the logarithm of x to the base a is equal to y, and a to the power of y equals x. A logarithm tells you what exponent you need to make a certain number. As there is no number that can be raised to power to get 0, so it is impossible to find log of 0. The modulus is defined as the absolute value of x is equal to x if and only if x is greater than or equal to 0, and the absolute value of x is equal to the negative of x if and only if x is less than 0. By definition, modulus of a number is always non-negative because it is basically magnitude or distance of a number from origin on number line. As we know, that distance can never be negative, so is the modulus. If we have a number with a negative exponent and then we take the reciprocal of that number to make the exponent positive. In case of 0, it will be as follows. Exponentiation is defined as repeated multiplication of the number, and 0 remains 0 irrespective of how many times you multiply it, so the above equation will become this. We are left with something over 0, and yeah, that's not allowed. Infinity is not a number. It is a concept used to describe something that has no ends or limits, but it is not a numeric value. If we allow multiplication of infinity with 0, the result will be undefined or inconsistent, and it will also violate some usual properties and laws of mathematics, such as a distributive property. Scalars are the quantities which only have magnitude, but vectors have both magnitude and direction or dimension. Scalars are added by simple arithmetic operations, but addition of vectors requires geometric transformation, so they can't be added. Determinant is a scalar value that can be computed from elements of a square matrix. In non-square matrices, they have unequal number of rows and columns, and the columns and rows are not linearly independent. Determinant represents scaling factor of area or volume in linear transformations, which only applies to square matrices. The inverse of a non-invertible matrix does not exist because its determinant is 0. The formula for determinant is this. So if the determinant of A is 0, then A itself must be 0. It involves division by 0, which is not allowed. Also, non-invertible matrix has linearly dependent rows or columns. If matrix A has an inverse, then it results in identity matrix when multiplied by its inverse, which is the product of matrix A and its inverse a to the power of -1, is the identity matrix I. And a non-invertible matrix has no matrix that can be multiplied by it to get an identity matrix. Logarithm is defined as the inverse operation of exponentiation. For example, the log of x with base a equals y, and a to the power of y equals x. A logarithm tells you what exponent you need to make a certain number. As the base of logarithm is always a positive number, there is no real number that can be raised to power to give a negative number, so it is impossible to find the log of a negative number. Scalars are just numbers, while matrices are arrays of numbers with specific rows and columns. Matrices can only be added with other matrices of same order. Also, scalars have no dimension while matrices have them. Derivatives require a function that is continuous and smooth. Basically, derivatives are slopes of tangent lines, and tangent lines cannot be drawn for non-smooth functions, and they may have corners or jumps in their graphs. Also, if the graph of function has a vertical tangent, it is non-differentiable. Eigenvalues are defined as scalar solutions to the equation matrix A multiplied by vector x is equal to scalar lambda multiplied by vector x. A non-square matrix has an unequal number of rows and columns, and the rows or columns are linearly dependent. Non-square matrices are not invertible, and being non-invertible is a requirement for eigenvalue calculations. Eigenvalues can be found only if matrix is invertible, has linearly dependent rows and columns, and can be diagonalized. The square of a matrix A can be found by multiplying it by itself. Matrix multiplication requires compatible dimensions. Specifically, number of columns of the first matrix should be equal to the number of rows of second matrix to be multiplied, like matrices of dimension m times n and nxp are comfortable for multiplication. In a non-square or rectangular matrix, the number of rows and columns are not the same, so when we multiply it by itself to find square, it does not satisfy the above condition for matrix multiplication. Keep in mind that all of the points we have discussed are not allowed in standard mathematics and can be extended or generalized in advanced mathematics, but these extensions require careful definitions and interpretations. While using BODMAS or PEMDAS, it is a common misconception that division precedes multiplication and addition precedes subtraction. But the fact is that division and multiplication are of equal importance, and addition and subtraction are of equal importance as well. They are solved from left to right. PEMDAS stands for P parenthesis, E exponents, M or D multiplication or division, and A or S addition or subtraction. Here is an example of this. 2 cubed minus 8 divided by 4 times 2 plus 7. First, we solve the exponent, and as we are working from left to right, division will get preference over multiplication. Then we do multiplication, and as we are working from left to right, subtraction will get preference over addition, and finally addition. Sometimes, students cancel out terms without keeping in mind the rules of cancellation. Consider the following example. Sometimes, students cancel out the term x squared, and they are left with this. That is not true. Here, we would have to factorize the terms first, and the correct cancellation will be this. Consider an example of this. We cannot simply cut the squares with the square root. If squares are being added or subtracted, it can be cancelled out if we have whole squares instead of individual squares. Here is another example of exponents with a different mistake. Here is what we have, but it should be this. And we open the exponents in the reference of Pascal's triangle. Sometimes, not using parentheses, the result can be completely changed. Look at this example. Here, the square is of 4 only, so the minus remains unaffected. We write it as this. While in -4 squared, the square is of -4, so we will write it as minus 4x minus 4 equals 16. Like terms are those which have the same variable and exponent. In algebra, like terms are to be added, and unlike terms cannot be combined. For example, 2x plus 3 can't be equal to 5x because 2x is a variable term and 3 is a constant. But if we had, let's say, 2x plus 3x plus 5, that would be equal to 5x plus 5. Here, we combine the terms with the same variable. Similarly, if the variable is the same but the exponents are different, well, then we cannot combine them. For example, in nx to the power of 3 plus 3x to the power of 2 plus 5x plus 7, we have 4 different terms and none of them can be combined. Splitting means to break down the fraction into 2 or more fractions. So if we have 1 over x plus y, we cannot split it like 1 over x plus 1 over y. We cannot split the denominator like this. But if we had more than one term in the numerator, like 2x plus 3 over x plus y, it can be split up as 2x over x plus y plus 3 over x plus y. We have split the numerator, and well, the denominator remained the same in both fractions. If you guys know any other things that are disallowed in math, make sure to let me know down below.